Hello and welcome back everyone. So I just wanted to make a quick video introducing GitHub. I'm just going to talk about how you can use it and just some just the very basics of GitHub. So when you go to github.com, there's this little form that you can fill out to create an account. I believe my account is Evan Daly. Yeah, it's already taken. Put in your email address and a password and click sign up for GitHub. It's completely free. If you want to host private repositories, I believe it's like $7 a month, and you get unlimited private repositories. So yeah, go ahead and sign up, and then download the desktop app. The easiest way to use it is with this app interface. You can also use the shell. So if you come up here and click on Open in Git Shell, that's going to open up this terminal. And then you can type git commands, so like git status. That tells me what branch I'm on and if there's any changes on that branch. I'll get into that a little bit more later on in this video, but for now we're just gonna use the basic user interface. So again, go ahead and create an account, download the app, and now you should be caught up with me. So over here you can see that I have a few repositories on my local system. If I wanted to create a new one, so let's just do that. Let's go up here and click create. I'm going to say test repo, and it's going to store it in this folder structure. So it's going into GitHub/test repo. I'm going to click create repository, and so currently it's empty. If I right click over here, I can open that in an Explorer, and you can see it's an empty file. It did add this git attributes and git ignore. So git attributes you can use for different things like I think you can use it to change the default line endings. So by default it looks like it's using LF. I haven't messed with that too much. I have messed with the git ignore a little bit more. So what this file does is basically typically anything you put in your repository folder will be synchronized with GitHub unless it is included in the git ignore file. So like if I had PHP files in my repository, but maybe I don't want them to go up to the server, I could say don't include anything ending in .php. Or I could specify don't include passwords.php. And then when I save that, it should actually register a change here. So now if I go back to the user interface, you can see we're in the test repo. It's only currently local on my system. If it had been pushed up to GitHub, you would see it in this top list. But right now it's just local. You can see we've got one change. The git ignore file changed. Now if I go back here, if I add a file, let's say new text document, passwords.txt. Whoops. Now come back here, and you can see it sees the change. It knows it's there. And so now if I wanted to push this up to GitHub, I could name my commit and then say commit to master. I'll touch on that a little bit more later. But just going back to the whole git ignore thing, we want it to ignore files called passwords.php. So right now it sees the change, but if I change this to passwords.php, yes, now you can see the change is gone. So it's not actually going to track that change and push it up to GitHub. That is an ignored file. So why don't we just delete that and remove that change from this guy. So as far as the git ignore, when I'm doing Visual Studio projects, I usually don't worry about this too much unless I'm doing like game dev. Like if you're doing game dev with Unity, Unity generates a lot of meta files that you don't need to push up to the server. Personally, with Visual Studio, I haven't done it too much, but there is this great example file. If you just Google GitHub Visual Studio ignore file, you'll get this whole thing. And so if we wanted to, we could just copy that. I'm just going to grab this whole thing, copy it over here, save it, and now Now any like weird Visual Studio generated files will be ignored. So like anything built by Visual Studio, like test files, stuff like that, that it'll prevent like any unnecessary files going up to the server. So anyway, now we've got our changes to the git ignore. I'm going to go ahead and call this update git ignore. Commit to master, and now I'm going to click on publish. So usually this would say sync, but since this is our first time ever doing anything with this repository, it's asking if we should publish it to the server. So I'm going to say this is a test repository. Do we want it to be private? No. Yeah, might as well. And this little thing indicates which account it's with, so I'm going to choose Evan Daly and publish test repo. So now you can see it moved up and it's in this first group. If I right click on it, I can view it on GitHub. You can see that it is private because it's got this little lock right here. I'm going to click view on GitHub, and it says page not found, and that's because I'm actually not signed in. So that's great. That verifies that this is in fact a private repository. Only I can see it. So I'm going to quickly log in, and there it is. Only visible to me. It's got 2 commits, so the initial create and then the updating of the git ignore file. So I'm just going to go ahead and close that. Now I think I'll go ahead and create a Visual Studio WinForms project right here. So let's open Visual Studio, and I'm just using the community edition of Visual Studio. It's free. So why don't we go new project, and I think I'll do WinForms. We'll just call it test app. Now I want to make sure that I store it in the GitHub repository. So I'm going to click on Browse, Documents, GitHub, Test Repo, right there. Okay. So it's creating the app. Now if I jump back to Visual Studio, or sorry, if I jump back to GitHub, you can see it registered most of the changes. Visual Studio did create some meta files that we don't want to include, so the git ignore file is actively excluding those. But everything that should be synced is now in this list. So I'm going to say create empty project, commit to master, and sync. And so now what sync does is it checks if there's any conflicts. So like if I was working on something and then someone else was working on the same file, and then we both tried to push those into master, if our changes conflicted with each other, it would give us a warning, and then we would have to resolve that. I can touch on that later. But as long as there's no conflicts, basically what the sync button does is it just takes what you committed and it pushes it up and saves it on the server. We've got so many files open right now, so let's close this guy. Oh yeah, and so why don't we just make a quick change. So I'm going to open my toolbox and just add a button. Alright, so now we just have this simple app. All it has is a button. It doesn't actually do anything. If we go back to GitHub, you can see it hasn't actually done anything. Why don't we try to save that? Okay, so I just had to hit Control S for save. Now you can see we updated the designer file. If we click on it, we can see line by line what we did. So this line got deleted. That's signified by the fact that it's in red and there's a minus here. And then all of these lines were added. If I wanted, like a lot of people don't like this user interface, you can control everything using the git shell. So why don't we try git status. It says I'm on branch master, I'm up to date with master, nothing to commit. Oh, I'm looking at the wrong repository right here. Sorry about that. So why don't we try this again? Open and git shell, git status. Alright, so now you can see it's the same thing as over here. We've got designer.cs was changed, test app CS project, and resx one thing I can do is, this is only showing the changes of the files. It's not actually showing the line-by-line thing that we get over here. If we need the line-by-line difference, you can say git diff and then the name of the repository. So in that case, it would be test repo. And I'm not sure if this is going to work. I'm not sure if it needs more of a file path before it, something like that. But let's just try this. Git diff test repo, go. Ambiguous argument test repo. Okay, so I'm not sure what the full path of this would be. Let me check the repository. GitHub. Oh, actually, I think it'll just be evandaily/test repo. No, it's still not right. So I'm not actually sure what the path to a personal repository would be. This usually works for me at work, but we have a standard naming convention that I always follow. So I don't know about that. Anyway, the git status will still give you the difference here. Why don't I just try git diff? Oh, okay, so that worked. If you just do git diff star, I'm not sure why that actually worked, but we're basically just saying compare what we have here against anything else we can compare against. So now you can see it looks pretty similar to this line here. So we've got that red line corresponds with this red line. These are all additions. So now that we can verify that we're tracking the right changes, I can say git commit, actually git add star, git status. Alright, so previously when we did a git status, we had these 3 red files, and that means changes happened on those files. Like, we know that there were changes, but we haven't actually told GitHub that we want to save those files to the server. So when you say git add star, you're saying find anything that changed and add it to the collection of stuff I want to push to master. So we did git add. Now that these are green, we can tell that we're ready to save them to the server. So now we can say git commit, and we're just going to name the commit, and let's just call it test commit. Actually, why don't we call it something more meaningful? Adding simple button. Error path spec, adding simple button did not match any files known to Git. Oh, sorry, I messed it up. So git commit, and then -m stands for message. So we're going to commit these files to the server, and we're going to name it adding simple button. Okay, so now three files were changed, 145 insertions. That means it worked. So our changes got pushed up to the server. And now if we want to, we can verify that on github.com. So you can see we now have 3 commits. If I click on that, you know, I don't actually see it yet. The last change we see is from 6 minutes ago, which is quite strange. Usually it's pretty much instant. I think I can just assume that the website is behind. That's very strange. Another possibility is that it did not commit to the right thing. Create mode, test add. You know, that's very strange. Usually it just works. So anyway, I might have done that wrong, and if you don't want to, you don't have to use this interface. This interface can be kind of nice, especially for resolving conflicts if 2 people are working on the same file and the code gets kind of messed up. This can be very useful. The user interface is a little bit limited, but in most cases, especially if you're working completely on your own, the Git UI right here is going to be all you need. So I don't know why this isn't showing up on the actual website, but if I jump back over to this page, it knows that the changes got pushed up because it's not seeing any changes. It's comparing what we have locally to what's on the server. It's saying they're exactly the same, and so it's not listing anything here. So what I did here, actually, it did for sure push the files up because they're no longer showing as changes here. Yeah, it's still not showing up there. That is so strange. So anyway, I'm just going to close out of that. Just as a quick example, why don't I open up Paint? So imagine we have this remote server. So we'll call this remote. That's going to be way too big. 32 remote. And locally, this is your computer right here. So just to recap, what we did initially was create the repository. And so let's just say this giant rectangle at the top is the repository on GitHub. And then we cloned that onto our computer and we wrote some code. We created this simple desktop app. All it is a form with a button. And then we committed that to GitHub. So let's just draw this arrow. We pushed it up. Now it lives on GitHub. Now, if you're working on the files on your own, this is really like all you need to do typically. You just save it to master, and then anytime you want to make changes, or anytime you're on a new computer, you can just simply download master to your computer, make your changes, push them back up. So let's say you want to add a button, add the button, save it, push it back up. Now it's on master. Now here's where branches come into play. So this code right here on master on the server is the official version of the project. This is the pristine version that should always work. Master should never have any sort of problems. Like if you're writing code, you should be testing it as you go. And then once it's in a working state, then it can go into master. You never want bugs in master. You never want anything incomplete in master. So let's say you want to add a feature, but it's going to take a few days or a few weeks to build. Or maybe you're working with a team of people and each person is working on a different feature. You don't want everyone to be working on master because you can have conflicting code, you can change things at the same time, you can do a lot of things that kind of mess up the pristine version of the project, which is what master is supposed to be. So that's where branches come into play. So on the server, we're going to create a branch, and what that does essentially is clone this project. And so they both live on remote. They're both hosted on GitHub, but one is called master and one will be called feature slash why don't we just call it text field. And now, so why don't we just do that? So I'm going to open up GitHub. Right now you can see we're on master. It shows here. If I click on compare, we're on master. I'm going to click on this button, and that's going to create a new branch. You can also create branches in the shell. That's a little bit outside the scope of this video. But again, we're just going to create a new branch, and it's going to be called feature slash text field. Alright, so now we're on that branch. If I click publish, it's going to push the branch up to the server. And now, essentially, we're in this stage. We did it locally, and then we published it. So basically, we we started on this end and then pushed it up. We pushed it up like that, and so now it exists here. But you could go the other way. You could clone it, you could create the branch on the actual remote server using github.com or anything like that, and then download it. Either way, you're going to get the same thing. You're going to end up with this box down here. And so now we've got our pristine version of the code living in master. We've got the code that we're going to edit, and that's on feature/text field. So since we're on that branch now, why don't we create a text field or a text box. So I added it. I'm going to save. I'm going to jump back over to GitHub, and I'm just going to say adding text field, go. Sync. And so this is the stage where things are kind of in flux. Like it might not necessarily work right away. I have to test it. It's in progress. But as I go, I can keep pushing and pulling from the server. So maybe I haven't finished with the feature yet, but I've made some progress on it. I want it to save. I want to make sure that it's backed up on a server. So I'm going to push that up to the branch. I can pull it down from the branch, and then I'm just going to stay within these bounds until I finish with it. And then once I finish with the feature, that's the point where you create something called a pull request. That's where you're saying, my feature is finished, it's done, it's ready, I want it to be approved and pushed into master. So at this stage, usually, like especially if you're working with a team of people, people would review it before it goes on to master. But if you're just doing it on your own, maybe there's no approval process. Maybe you just merge it in because you know it's ready. But yeah, typically with bigger teams, you need at least 3 people to look over all the changes and then approve it before it can be merged into master. And that's really it's a really nice workflow to do it that way, because people can see line by line what you changed, and they can make comments on it. And so if they don't like the way you're doing something, or if the syntax is kind of weird, or if you're doing it in a way that's really slow, people can kind of check that and recommend better ways to do it, like as you're working. So it's a really great system. I really like it. So why don't we, like let's say that feature is done. Now we want to merge it into master. If I go back to the test repo, you can see these are all the files. There's 2 branches. We've got master and feature/text field. Now if I wanted to, I could create a new pull request. So this is a request. It's saying my section is done. I'm asking my team to pull my changes into master. Look it over, make sure it's good, and then merge it in. So we're going to create that pull request, and it has to be from text field into master. And actually, I haven't done it this way on the website. The company I work for uses a slightly different interface, so I'm not sure if it's saying go left to right or right to left. There isn't anything to compare. Why don't we flip that? There we go. So now we can see we added a simple button, we added a text field. And again, it shows line by line everything that changed. So we're going to quickly create the pull request. And yeah, you can also set up like requirements on the repository that say you need this many people to review the branch before it can be merged. I haven't set anything up like that on this branch, so it doesn't require any approval process. I can just create the pull request and merge it in right away. So let's go ahead and do that. Confirm merge, and you know it's showing 2 different commits. simple button and simple text field. And so that actually explains why I couldn't see that commit earlier. It was only showing these three, the simple button and the text field. I guess I had done them both on the separate branch, and so I wasn't seeing those commits on master. But now that it's merged in, we can see all the changes on master since the beginning of time. So I hope that explains that part of it. Let's see. I covered creating the repository, creating a basic project, uploading it to GitHub. Again, the really nice thing about GitHub is that it's only syncing your files, and so you can use whatever program you want to edit the code. Like I created it in Visual Studio. I've got all the files right here. I can push them up. I can pull it down, and I don't have to use any specific editor. Like I just have the source files right here. At work, I use PHP Storm because I'm mostly using PHP. What else? I could talk about resolving Git conflicts. There is a potential to create conflicts when people are working on code at the same time. So let's say I'm working on the user interface right here. I'm adding buttons and text fields and stuff like that. And then maybe someone else is also adding buttons and text fields. GitHub usually does a pretty good job syncing those changes. Like maybe I finish my changes first. First, I push it up to master. Somebody else finishes their changes, pushes it up. As long as we didn't actually edit the same line of code, usually GitHub figures out who changed what and where it should go, and it's all fine. Occasionally, GitHub can't figure it out. Like maybe we both changed the same line of code, and GitHub doesn't know what to do with that line. In that case, there would be something called a Git conflict. And typically what you would do would be to just say git pull. And so like let's say I'm working on something, someone else changed the exact same line of code. When I try to push my changes up to the server, it's going to tell me I can't because there's a conflict. And so what I have to do is do a git pull. That's going to take what's on the server, merge it into what I have, and then it's up to me to figure out how to fix it. And usually it's pretty straightforward. GitHub does a really nice job showing you where exactly the conflict was, and it'll show you what you changed and what they changed side by side. And so then you can just kind of compare the two lines and say, well, they did this, I did this. It really should look like this in the end with both our changes. So you do that, and then you would just go through the same process. Git add star to that's going to tell Git that you want to save all your changes to the server, and then you would say git commit message, this is a commit, and then git push. And that's all there is to it. Again, you could do the same thing with the Git user interface. It's a little bit harder to resolve those Git conflicts here, but it is very doable. Let's see, were there any more questions to answer? Another common question is, does Git work nicely with Visual Studio? I would say yes. Occasionally Visual Studio can generate weird meta files. So like let's say I'm editing the user interface, someone else is also editing the user interface. The code that defines these buttons is usually pretty easy to merge together with, like, usually that won't create too many Git conflicts. But Visual Studio can create weird metadata that can be really hard to look through as a human if you're trying to figure out how to resolve those conflicts. But generally it's not too bad. I find that usually it's pretty easy to resolve. So I think that's about it for this video. Thank you guys for watching, and I'll see you next time.